Dili, yeah. Okay, good morning, everyone. This is your Math 100 instructor. I am Cindy Bonono, and I have been handling this subject for about more than 3 years now. Okay, so let's have our discussion. Today, we will discuss the sequences and series. This is still part of the course Mathematics in the Modern World. Now, there are a lot of types of sequences and series. However, we will only be dealing with four of its types today, namely the arithmetic, the geometric, harmonic, and the Fibonacci sequence. Let's begin with the arithmetic sequence. So we have here a sequence in which every term is created by adding or subtracting a definite number to the preceding term is considered as arithmetic sequence. So this means to get the next term of the sequence, we will be adding a fixed number. And that is considered as the common difference, or which is mainly denoted by a small letter d. Now, how do we get the common difference? That is by subtracting or getting the difference of every two terms in the sequence. So if you do have the sequence a sub 1, a sub 2, a sub 3 until a sub n, you will be subtracting backwards. So you will have a sub 2 minus a sub 1, a sub 3 minus a sub 2, a sub 4 minus a sub 3. So these um, numbers should come up with the same difference for you to identify that the given sequence is arithmetic. Next is we have the geometric sequence. This is considered as a sequence in which every term is obtained by multiplying or dividing a definite number. When we say definite, that means it's fixed, it's constant, with the preceding number is known as geometric sequence. So if in arithmetic we do have the common difference, here in geometric we have a common ratio. Now, how do we get the common ratio? Given the terms in your sequences, all you have to do is to divide every two terms. So you do have there a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, and a sub 4 divided by a sub 3. So these three, or these every quotient should be the same whenever you divide every two terms in the sequence, or the term in the sequence will be divided by its preceding term should be getting the same result. Now we also have the harmonic sequence. It's a series of numbers is said to be harmonic tau if the reciprocals of all the elements of the sequence form an arithmetic sequence. So for example, you do have it in here a sequence a sub 1, a sub 2, a sub 3, and a sub 4. If you are to get its reciprocal, you will be getting 1 over a sub 1, 1 over a sub 2, 1 over a sub 3, and 1 over a sub 4, and so on and so forth. So this only means that if a sequence, or if the reciprocal of the terms in the sequence will create a arithmetic sequence, then automatically it is harmonic. You just have to remember harmonic sequence is the reciprocal of arithmetic sequence and vice versa. Okay? Next, we do have the Fibonacci sequence. Fibonacci numbers form an interesting sequence of numbers in which each element is obtained by adding two preceding elements, and the sequence starts with 0 and 1. Now, unlike the arithmetic and geometric sequence, Fibonacci sequence is fixed. No? Every term is irreplaceable. It always begins with 0 and 1. Now, we cannot find any other examples of a Fibonacci sequence because, again, each term in the sequence is fixed. It only matters with the interval. Do not worry because we will be digging one by one in every sequence. Okay, let's have first the arithmetic sequence. Now we have the general form of the arithmetic sequence that is given by a sub n is equal to a sub 1 plus n minus 1 times d. Here, a sub n is the term that we are looking for, or the nth term, the missing term of the sequence. A sub 1, this is our first term, all right? And this is the position of the term in your sequence. So what position does it hold? What place does it hold? Is it the first term, the second term, the third term, and so on and so forth? Now, the here, as what I have said, this is the common difference. So when we say common, it's the same to every term. Difference because we are using the operation subtraction. Okay, let's take a look at the following sequences. We have the sequence 1, 4, 7, 10, 13, and 16. Now we are tasked to look for a sub 15 or the 15th term of the sequence. But before we proceed, let's verify first if this is arithmetic. Now we get the difference. 1 minus 4, that gives us 3. 7 minus 4, that gives us 3. 10 minus 7, that gives us 3. 13 minus 10, that gives us 3. The same goes with 16 minus 13. So again, each term will be subtracted by its preceding term. Kanang nag-una nga term sa iyaha. Okay? Now, since every two terms has the same difference, which is 3, thus this is an arithmetic sequence. Now, we are safe to use the formula to look for the 15th term. So we have a sub n is equal to a sub 1 plus n minus 1 times t. Now, after you write down the general form, you then substitute everything that is given. So a sub n will be replaced here by a sub 15. Why? Because we are looking for the 15th term. A sub 1, that is the first term, we do have in here 1. Okay, before we jump into the next part, let me just show you. A sub 1 here this denotes the first term. A sub 2, that's the second term. A sub 3, that's the third term. A sub 4, that's the fourth term, and so on until a sub n. Okay, now we have here plus our n here, that gives us 15 minus 1 times our common difference, which is 3. Take note that whatever the value of n on the left side should be the same on the right side as well. Okay, let us simplify. You have there 1 plus 14 minus 1. This gives us 3. Okay, so we have here 1. This is 14 already. Okay, 15 minus 1, that gives us 14. So 14. All right, 14 times 3. 4 times 3, that gives us 12. 1 times 3, that gives us 3, plus the carry 1, that gives us 42. So 42 plus 1, that gives us 43. Therefore, the 15th term of this sequence is just equal to 43. But if you want to compute it manually, since you already know what the common difference is, therefore, if you are to continue the sequence, all you have to do is to add 3 to every term. Say, for example, this sequence, you do have here 1, 4, 7, 10, 13, and 16. So how will we get to the 15th term? We add 3 to every term. So 16 plus 3, that gives us 19, plus 3, that gives us 22, plus another 3, that gives us 25, plus 3, that gives us 28, plus another 3, that gives us 30, 28, 29, 29, 30, 31. Plus another 3, that is 34. This is 37. This is 40. And this is 43. So let's count if the 43 in here is the 15th term of the sequence. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there you have it. Whatever method you will be using, you will still come up with the same answer. Because again, in mathematics, there are a lot of ways to kill a cat. There are many ways to kill a cat. And also, do not just stick to a single method. If it is applicable and it does not violate any rule in the mathematics, then you are free to do it. Okay. Next is we do have this is number 1, by the way. Next, we'll solve number 2. So you do have the sequence negative 6, negative 2, 2, and 6. Negative 6 is our first term. Negative 2 is our second term. Positive 2 is our third term. And we have here positive 6 is our fourth term. So let's get the difference. We have negative 2 minus negative 6. That gives us positive 4. So let me just show you how that we do it. Okay. Negative 2 minus negative 6. Now, this is from a sub 2 minus a sub 1. All right, so we copy negative 2. Then we have here negative times negative. That gives us positive 6. So the sign that we will be copying is the sign of the bigger number, which is 6. Now, 6 is positive, therefore the answer is positive also. Now, negative 2 plus 6, that gives us positive 4. The same here with 2 minus negative 2. So this is a sub 3 minus a sub 2. Our third term, that is 2, minus our second term, that is negative 2. So this gives us 2. Negative times negative, that is positive 2. So we have in here positive for the same difference. Okay, then we have 6 minus 2, that gives us 4. Now we have confirmed that they have the same difference or the common difference. Therefore, we are free to use the given formula. So you have there a sub n is equal to a sub 1 plus n minus 1 times d. Okay, next is we substitute the given terms. Here, a sub 9 is the missing term, so we replace that to a sub n. So we have here a sub 9 is equal to our first term, that is negative 6, plus the value of our n, or the position of the missing term, is on its ninth place. So we replace n with 9 minus 1 times our common difference, which is 4. Okay, so this gives us negative 6 plus 9 minus 1, that is 8, times 4. That gives us 8, 6, 9. Okay, times 4, that's 18, plus 18, that gives us what? Is it 18? 9 minus 4, that's 8. Okay. So 16 plus 16, that gives us 32. So negative 6 plus 32, that gives us 26. Therefore, the ninth place of this sequence is positive 26. The same result if you are to use this method. You manually add the difference to every term. Again, if you are to continue the sequence, then you add the value of d. But if you are to go backward to the left, then you subtract the value of d. Okay? Next, or you subtract the term by its preceding term, rather. Okay, we'll proceed to number 3. Now, before we continue, let us verify first again if this is arithmetic. So you do have there 2/3 minus 1/3. That gives us 1/3. Ma'am, how did you do it? Okay, let's have a preview. You have there a sub 2 minus a sub 1. Our a sub 2, or the second term, that is 2/3, minus our a sub 1, or the first term, that is 1/3. So in this case, we have a common denominator, rather. We have 3 on the first term and 3 on the second term. So all you have to do is to copy this. Now 3 divided by 3, okay? Oh, we no longer have to do that because we will still be getting the same result. Okay, so we have the common denominator 3. So let's just copy that one, and then you subtract the numerator 2 minus 1. That gives us 1 all over 3. So the difference here is 1/3. Next is you go to a sub 3 minus a sub 2. You have there our a sub 3, that is positive 1. Our a sub 2, that is 2/3. So we have a different case in here. 1 is a whole number. Automatically, its denominator is 1. Okay, we have different denominators. So we get the LCD, or the least common denominator, or the smallest number that can be divided by both 1 and 3. That gives us 3 only, right? 3 is divisible by 1, and 3 is divisible by 3. It means divisibility. It means it can be divided by that number. Okay, so 3 divided by 1, that is 3, times our numerator 1. Okay, we copy the operation subtraction. 3 divided by 3, that is 1, times the numerator 2. Now, we simply have it in here. Let me just erase this. 3 times 1, that is 3. 2 times 1, that is 2. So we have 3 minus 2. That gives us 1 all over 3. Same gihapon. We have here 1/3. Next, just to make it sure. Okay, we have a sub 4 minus a sub 3. So a sub 4, that is 4 over 3, minus, we have our a sub 3, that gives us 1. The same case on our previous digits. So you have there 1 is the denominator because 1 is a whole number. And then we have here the LCD, that's 3. So 3 divided by 3, that is 1 times 4, that gives us 4. Copy the operation subtraction. 3 divided by 1, that is 3 times 1, that gives us 3. 4 minus 3, that gives us 1. Copy the denominator 3. Thus, we still have the difference, which is 1/3. Now, we are free to use the formula above. Okay, let me just erase this one for a while. It might take a few seconds or a minute, probably. Okay, just give me a few time erasing these digits. I'm having a hard time actually. Okay, let's do this. So we have the formula. A sub n is equal to a sub 1 plus n minus 1 times d. Okay, here we are looking for the seventh term, so we replace a sub n with seventh term. Our first term, that is 1/3 plus. We have here the position of the missing term is on the seventh place, so we replace it with 7 minus 1 times our common difference, which is 1/3. Now, let us copy 1/3 plus. We have 7 minus 1, that is 6 times 1/3, that gives us 6 over 3. Now, when the operation is multiplication, you do numerator by numerator, denominator by denominator. Okay, so let us simplify. Here, we have the same denominator, so all we have to do is to copy it. We have 3, and then 6 plus 1, that gives us 7. Therefore, the seventh term of the sequence is just 7 over 3. Or if we are to convert this one into a mixed fraction, because this is improper fraction. Now, a mixed fraction has both the fraction and the whole number. So how do we do that? We have here 7 divided by 3. There are 7 divided by 3. There are two threes in 7. So we have 2. 2 times 3, that gives us 6. So we have here 1. Now, your answer here above will be the whole number. Your remainder in here will be the numerator. And the divisor here will be the denominator. So the answer is just 7 over 3, or 2 and 1/3. All right. Now, let us try to use the same general formula to look for the unknown term. Right? So, what if the terms are given, but we are to look or to identify its position in the sequence, or we are to look for the common difference? Just like in this example, we have the first term given, that's a sub that's 5. We have a sub n, that's 395, and we have the common difference d, which is equal to 5. So your task is to find n, or to look for the position of 395 in the sequence. Using the same formula, you do have there a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is given in our problem. That's 395. A sub 1 is given as well. So we have here 5. Basically, what you will do here is that after you write down the general formula, you just directly substitute all the given terms. Okay? Then we have here plus, we have here n minus 1 times the common difference, which is 5. Okay, question, why didn't we replace n with any digit? Because that is the thing that we will be looking for. Okay, so we have there 395 is equal to 5 plus, let's substitute, distribute brother. So n times 5, that gives us positive 5n. Negative 1 times 5, that gives us negative 5. Okay, so we are to subtract this one. It will give us 0. Now, the only thing that's left is 5n and 395. Now, you go back to your goal, which is to get the value of n. So how will we do that? We divide both sides by positive 5. Okay, this gives us the value of n. We have there 395 divided by 5, that is just equal to 79. Therefore, the value of our n here is 79, or 395 is just the 79th term in the sequence. Okay, Next is we do have here find the common difference or the value of d and the next three terms of the sequence. So let's identify first the given terms. We have here a sub 1, and this is the missing term a sub 2, a sub 3, a sub 4, and we have another given term that is a sub 5. So basically, we only have two given terms. The first term, which is 2, and the fifth term, which is 0. So using the same formula, you have there a sub n is equal to a sub 1 plus n minus 1 times d. Okay? Now, a sub n can be replaced by a sub 5. We can use a sub 5 as a substitute because it's given, right? So again, you substitute any possible values that is given. Okay, so this becomes a sub 5 equals a sub 1 plus n will become 5 because our value on the left side of n is just 5. Okay, so you do have there 5 minus 1 times d. Again, you do not replace d with anything because it's the thing, it's the value that we are looking for. Okay, a sub 5 is given, that is 0, so you substitute. A sub 1 is given by 2 plus you have there 5 minus 1, that gives us 4 times d. Okay, so it gives us 4d. Let's just remove this one. Let's write down for the directly. Now our goal is to get the d, so we can use subtraction property of equality or the SPE. We will subtract both sides by positive 2. Okay, so we have here 0 minus 2 is equal to 2 minus 2 plus 4d. This gives us positive 4d, which is equal to negative 2. Now, how will we do this one? How will we simplify this? We divide it by positive 4. Okay, so you do have there the value of your d is just equal to negative 1 half. Now we already have the value of t. The first problem is solved already. Now we are to move to the next three terms. If this is the case, it only involves small terms or let's say a few terms only, then you just add directly the value of d to your terms. So you do have there to get a sub 2, all you have to do is to add, right? You have there a sub 1 plus the common difference. Okay, so a sub 1 there, that is 2 plus our common difference, that is negative 1 half. Okay, so this becomes you have 2 minus 1 half. All right, so you have there the least common denominator, which is 2, and this is 1. 2 divided by 2, 2 divided by 1, that is 2 times 2, that gives us 4. Minus 2 divided by 2, that is 1 times 1, that gives us 1. So this becomes 3 halves. Therefore, the second term of our sequence is just 3 halves or 3 over 2. Now we proceed to the next term. We have there a sub 3. To get a sub 3, all you have to do is to add a sub 2 and the common difference. Okay, so you have there a sub 2, that is 3 halves plus negative 1 half. So this becomes 3 halves. Positive times negative, that becomes negative 1 half. Okay, in this case, we have the same denominator, so we copy the denominator. Then we have 3 minus 1, that gives us 2. 2 divided by 2, that gives us 1. Therefore, the third term of the sequence is positive 1. Now we'll move to the fourth term. So a sub 4 can be taken by adding a sub 3 and the common difference. We have here our a sub 3, that is positive 1, plus our common difference, negative 1 half. Okay, now we have here 1 minus 1 half. Okay, if you have 1 kilos and that is subtracted or that is reduced by a half kilo, so you will still be getting a half kilo. Therefore, the fourth term of the sequence is just 1 half. So there you have already completed the sequence. The first problem and the second problem are both solved. Okay, now let's move on to the next part of the sequence. We have here arithmetic sequence or finding the implicit formula of the sequence. The one that we have used previously was the general form, which can be applied to any examples or to any arithmetic sequence. But when we talk about implicit formula, this can only be applied to a particular arithmetic sequence. And that can be done, the formula can be derived by using another formula, which is a sub n is equal to d times n plus a minus 1, a sub 1 minus d. Okay, so in this case, we do have the same form. It just so happen that our c here is taken from subtracting d to a sub 1. For example, you do have there the sequence 15, 19, 23, and 27. So let's first verify if it's arithmetic. We get the difference of two terms. Okay, the term will be subtracted by its preceding term. So we have there 19 minus 15, that's 4. 23 minus 19, that's 4. 27 minus 23, that is still 4. Therefore, it has a common difference. Okay, now the next thing that we will do is to get its its implicit form. Okay, para ra sa iya pwede i-share. So you have a sub n is equal to d times n plus a sub 1 minus d. Okay, now for a sub n, all you have to do is to copy that. Then you replace d. The value of our d or common difference here is 4. Then n plus our a sub 1, that gives us 15, minus the common difference, which is 4. So we simplify. A sub n is just equal to 4n plus 11. Therefore, the implicit formula of this particular sequence is a sub n equals 4n plus 11. It means that this formula can be used to look for the next few terms of the sequence. So if you do have there a sub 1, a sub 2, a sub 3, and a sub 4, let's try to look for a sub 5 using this formula. Okay, this is a sub n equals 4n plus 11. So a sub n will be replaced here by a sub 5. This gives us 4 times 5 plus 11. So you do have there 4 times 5, that is 20, plus 11, this gives us 31. Therefore, the fifth term of our sequence is just 31. The same thing, if you will be adding 4 to 27, you will still come up with 31. Okay, so again, implicit formula, this is only given or can be used to a particular sequence in this case because we are talking about sequence man. Okay, next is we have the arithmetic series. Now, arithmetic series is just the sum of all the terms in the arithmetic sequence. So if you are to add every term, then that is considered as, or that is called arithmetic series. So basically, you will be adding all the terms. Okay, we're going round and round in this scenario. Okay, we have here s sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. Here, the n denotes the number of terms in the sequence. Okay, how many terms in the sequence. So the number of terms. A sub 1, that's the first term. A sub n, that is the last term. For example, we have 5, 10, 15, 20, and 25. So let's get the sum of these numbers. S sub n is equal to n over 2 plus times brother. Let me just remove this one. Erase brother, okay, times a sub 1 plus a sub n. So here we have 1, 2, 3, 4, 5, 5 terms. Therefore, n will be replaced by 5. Then you have there 5 over 2 times our a sub 1, that is 5, plus our a sub n, that is 25, or the last term in this sequence. So this gives us 5 over 2 times 5 plus 25, that gives us 30. Okay, so you do have there 30 divided by 2, that gives us 15. 15 times 5, that gives us 75. Therefore, if we are to add 5 plus 10 plus 15 plus 20 plus 25, you will get 75. Okay, next example. Find the sum of the numbers from 1 to 100. So this is already considered as arithmetic because we can find a common difference, man. Okay, 2 minus 1, that's 1. 3 minus 2, 4 minus 3, 5 minus 4, and so on. Okay, let me just write down 1 in here because that's for problem number 1. We'll proceed to problem number 2 and we use the same formula as on n over 2 times a sub 1 plus a sub n. So here we have 100 terms. Therefore, s sub n will be replaced by s sub 100. Then you have here 100 divided by 2 times our first term, that is 1, plus the last term, that is 100. So this gives us 100. Now, 100 divided by 2, that is 50 times 101. Okay, so 5 times 101, that gives us 505. Adding 0 here, that gives us 5,050. Therefore, if you are to add 1 plus 2 plus 3 plus 4 plus 5 plus until 100, that will be equivalent to 5,050. You see, if you are going to add that one manually, it will consume you a lot of time. No, but because of the use of the formula, it's a lot convenient to us. So I hope that everybody was able to appreciate the beauty of these formulas and equations that have been discovered, that has been crafted, that has been derived by our mathematicians. Okay, next we have find the sum of the first 10 odd terms using the arithmetic series formula. So let's identify first what are the odd terms. Okay, when we say add, that bungkig, it cannot be divided by 2. When we say even, it can be divided by 2. So we have here 1, numbers that cannot be divided by 2, 1, 3, 5, 7, 9. We have 11, 13, 15, we have 17, and 19. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 terms already, and it's still considered as arithmetic sequence because we have a common difference. Now let's solve for that. You do have s sub n is equal to n over 2 times a sub 1 plus a sub n. Okay, here we have 10 terms, so n will be replaced by 10, of course. Now, this gives us 10 divided by 2 times our first term, that is 1, plus our last term, that gives us 19. So, there you do have 5, okay? 1 plus 19, that's give us 20, and then you multiply them together, that gives us 100. Therefore, if you are to add these digits, you will come up with 100. Okay? I hope that was clear, no? Next is we'll be using the geometric sequence. When we say geometric sequence, this is a sequence of the form a sub n is equal to a sub 1 times r raised to n minus 1. A sub n, this is the missing term. A sub 1, this is the first term. R, this is the common ratio. And then n here, that is the position of the term, which will be the same value on the left side, on the n, the variable n on the left side. Okay, so let's check. You have there the sequence 1, 3, 9, 27, and 81. So let's identify. You do have there the first term, the second term, the third term, the fourth term, and the fifth term. So to get the ratio, we divide the term by its preceding term. No, you have there a sub 2 over a sub 1. That's 3 divided by 1. That gives us 3. Next, a sub 3 divided by a sub 2. That gives us 9 divided by 3, which is 3. Next, we have there a sub 4 divided by a sub 3. That gives us 27 divided by 9, which is 3. Okay, next we do have there a sub 5 divided by a sub 4, that is 81 divided by 27, which is still 3. Now we have the same ratio, therefore it's verified that the sequence is geometric. Now let's look for, let's say, a sub 6. We'll be using this formula. We have a sub n is equal to a sub 1 times r raised to n minus 1. Okay, we have there A sub n will be replaced by a sub 6 because again we are looking for the sixth term. A sub 1, that is 1, times we have our ratio that is given by 3, our n, that is 6 minus 1. Okay, so this gives us 1 times 3 raised to 5. You have to take note that 3 raised to 5 is not the same with 3 times 5. Okay, your exponent will tell you how many times you will multiply the base by itself. In this case, our base is 3, our exponent is 5. So it means 3 will be multiplied by itself 5 times. Okay, we have 3 times 3, that is 9, times 3, that's 27, times 3, times another 3. Okay, let's use our calculator. What is 3 times 3? That's 9 times 3, that is 27, times 3, that is 81. So 81 times 3, I need a calculator for us to easily compute it. Okay, 81 times 3, that gives us 243. This means that the sixth term of our sequence is just 243. Now you can also, now for your task, I want you to gather at least three geometric sequences and you compute for its missing term. That depends on you. It will only serve as a seat work. Now feel comfortable in solving it. Next is we have the geometric series. Geometric series is just the sum of all the terms in the geometric sequence given by the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. So we have the example 3, 6, 12, 24 until its 10th term. We are to look for the sum of it. Now suppose you do not know what the formula is. So since the given terms are 3, 6, 12, and 24 only, 4 terms only, that means you have to look for the next 6 terms, right? It will take a lot of time. Again, it will consume time. But with the use of our formula, we can just directly get the sum without actually knowing the next few terms. So you do have there S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. Then you do the substitution. In this case, we are to look for the sum of the 10 terms. So you have there S sub 10 is equal to, we have our first term that is 3 times we have 1 minus the common ratio. So you have 6 divided by 3, that's 2. 12 divided by 6, that's another 2. The same goes for 24 divided by 12. So the common ratio again is 2, and we have it in here 2 raised to 10. All right, 1 minus 2. Okay, so we have 3 times 1 minus 2 raised to 10. That means the base 2 will be multiplied by itself 10 times. That will give us 1024 all over negative 1. 1 minus 2, that gives us negative 1. Okay, so we have here 3 times 1024 minus 1, that gives us negative 1023 all over negative 1. Okay, we simplify, this becomes negative 3069. Okay, divided by negative 1, that gives us positive 3069. There, we already have the answer. Now, if you want to check if the answer is correct, you use the previous formula in here to get the sixth term, the fifth term, sixth term, seventh term, eighth term, ninth term, and the 10th term. And then you add them manually. But still, you will come up with the same answer. Just so happen that the formula will help you solve it in a much faster way, in a much better way. Okay, next we'll move on to the Fibonacci sequence. As I have said, this sequence is different from geometric and harmonic because in here we have a fixed terms. Okay, so the beginning or the first term of the sequence is always 0 and the second term of the sequence is always 1. So ma'am, how do we get the next terms of the sequence? That is by using the formula. F sub n is equal to f sub n minus 1 plus f sub n minus 2. So n here dictates the term, the position of the term that you are looking for. Suppose we are to look for the third term. So this gives us f sub n is equal to f sub n minus 1, all right, plus f sub n minus 2. Since we are looking for the third term, we replace n with 3. This gives us f sub 3, which is equal to f sub 3 minus 1 plus f sub 3 minus 2. Okay? Now, let's subtract the subscript rather. Kanang gagmay na digits diha as a bus. 3 minus 1, that gives us 2, plus we have here 3 minus 2, that gives us 1. So now, it only means that f sub 2, the second term, and f sub 1, the first term, will be added to get the third term. So we have the second term, that is 1, plus the first term, that is 0. Adding them together, that creates 1. Therefore, the third term of our sequence is just 1. Now, there goes the definition of the Fibonacci sequence. That to get the next term of the sequence, all you have to do is to add the two preceding terms. So, what's the preceding terms of 1? You have there 0 and 1. 0 plus 1, that gives us 1. To get the next term, you then again add the two preceding terms. You have 1 plus 1, that's 2. 2 plus 1, that's 3. 3 plus 2, that is 5, plus 3, that gives us 8. 8 plus 5, that gives us 13. 13 plus 8, that gives us 21. Then 21 plus 13, that gives us 34, and so on and so forth. Okay, that's the concept there. Now, ma'am, what about the series or the sum of all the terms in the Fibonacci sequence? So you have there, let's say, the summation of f sub I, where I is equal to 1 until n. So that means um, we will be getting the sum of the first I terms of the sequence. Now, suppose we are to look for the sum of the first 8 terms of the Fibonacci sequence. So this becomes the summation of f sub I, where I is equal to 1 until its eighth term. So to do that, you have f sub n plus 2 minus 1. This is just the formula for the series. Okay, now since we are looking for the sum of the first 8 terms, n will be replaced by 8. So 8 plus 2 minus 1. This gives us f sub 10 minus 1. So f sub 10, this is the 10th term of the Fibonacci sequence. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the 10th term of the sequence is 34 minus 1. This gives us 2. 33. So it means if you are to add, let's say 0 plus 1 plus 1 plus 2 plus 3 plus 5 plus 13, okay, this is 1, 2, 3, 4, 5, 6, 7, okay, plus 13, plus 8 rather. We need 8 also. Plus 8 before 13, okay, plus 8 plus 13, you will be getting 33 as its total value. Okay, next is we have the last, the harmonic sequence. The harmonic sequence has the general form a sub n, which is equal to 1 over a sub 1 plus n minus 1 times d. Now, if you have noticed, the denominator of this sequence shows us the formula for the arithmetic sequence, right? Because the formula for the arithmetic sequence is just a sub 1 plus n minus 1 times d, right? So basically, if the sequence is arithmetic, then automatically it's harmonic. For example, we have 1/4, 1 over 7, 1 over 10, and 1 over 13. You can check this by using this formula. But again, to avoid long solutions, just check this if it is arithmetic. So let's get the reciprocal of these terms. When we say reciprocal, you will be changing the numerator and the denominator's position. So if you have there n over d, it will become d over n. For example, if you have 2/3, then you change their positions. 2 will become the denominator, 3 will become the numerator. Simple as that. Okay, changing positions of the numerator and the denominator. So you do have there Reciprocal of 1/4, that is just 4. Reciprocal of 1 over 7, that is just 7. Reciprocal of 1 over 10, that is just 10 over 1 or 10. Okay, automatically, if it's a whole number, no need to write down 1 as the denominator because that's understood already. Okay, but that's a widely accepted fact. Then the reciprocal of 1 over 13, that gives us 13. So you check if this is arithmetic. 7 minus 4, that's 3. 10 minus 7, that's 3. 13 minus 10, that is 3. Now, it's arithmetic sequence, hence this sequence is harmonic. Same with example number 2. 1/5, 1 over 10, 1 over 15, and 1 over 20. Get its reciprocal. Okay, 1/5, that's 5. 1 over 10, that's 10. 1 over 15, that is 15. 1 over 20, that is 20. So we get the difference, the common difference. 10 minus 5, 15 minus 10, 20 minus 15, you will come up with 5. Therefore, it's arithmetic sequence, and thus, it also follows that the given sequence is harmonic. Okay, so that concludes our discussion today. If you do have questions, you may write it down below, or you may just directly PM me or mention me in our group chat. That would be all. Thank you so much for listening. God bless. Goodbye.